Welcome back to Blissy Being. In today's video, we're gonna draw the Bode plot, both the magnitude and phase in step-by-step process. Initially, the step one, first we will work to plot the magnitude and then for the phase plot. For the magnitude plot, initially, you need to rearrange the given transfer functions. To rearrange the given transfer functions, the transfer functions would be arranged in such a manner that all your poles parameters should be in the standard form 1 plus st or 1 plus st form. So while rearranging, you will get that the constant 2 and 0.25 will come common and will get the transfer function in this form. And once you have converted your transfer function into standard form, your next step will be to replace the s by j omega, which is the frequency term. Okay, while replacing, you need to replace all the s by j omega. Okay, once you have replaced your s by j omega, step third will be to find the corner frequencies for the given transfer function. Initially, we are having constant simple poles, and there are two poles which are 0.5 j omega plus 1 and 4 j omega plus 1. So the lowest corner frequency of the given transfer function is 0.25 and the higher corner frequency is 2 radian per second. So note the both frequency. While noting the frequencies, remember the corner frequencies should be arranged in the ascending order so that you can plot them easily. And if you are having any problem regarding the finding the value of corner frequencies, you can mention in the comment section for the another detailed videos. As you can see in the above case, the lower corner frequency is 0.25 radian per second, so you need to choose it. And while choosing for this case, we have chosen the next initial frequency 0.1 radian per second. And once you have selected the initial frequency, all you need to do is find the starting magnitude. To find the starting magnitude, as your type of question changes, the formula also changes. There is a slight change in formula. As the question for the type 0 case, you need to use this formula. Once you have identified the value of the starting magnitude, all the task remain is to draw the table. If you will draw the table, it will be easier for you to track the diagram, and also all the data can be easily plotted. So let's draw the table for the given transfer function. For the table, we need to make the columns like factors, corner frequency, initial slope and cumulative slope. In factors, you need to place the factors that are available in your transfer function, the corner frequencies which you have find out from the factors, and the initial slope will be the slope the given factors deserve, and the cumulative slope will be the sum of previous initial slope and the new slope. So we'll add, this will be cumulative slope will be the resultant. So for this case, our initial factor is 10, and since the corner frequency of constant is very low, so we haven't mentioned the corner frequency, and we are unknown about the initial slope as well, and the constant have cumulative slope of 0 dB per decade. Next factor is next factor we will while placing the next factor, we need to see the corner frequency. As I had mentioned earlier, we need to arrange them in ascending order. That's why we'll place 0.25 radian per second earlier, and its factor also earlier. So we have placed 4j plus 1, and its corner frequency, we know this is the simple pole, and for the simple pole, initial slope will be, since they are on the pole section, so our initial slope will be minus 20 dB per decade. That's why we have placed, and then we will add the 0 minus 20 will give us minus 20 dB per decade. At last, our last factor is 0.5 j omega plus 1, whose corner frequency is 2 radian per second. So we have placed that in this column, and initial slope, both the factors are similar, so it's minus 20 dB, and we'll add minus 20 dB of previous and minus 20 dB, it will be minus 40 dB per decade. After finding this table, or after drawing this table, all we need to do is we need to plot the Bode plot. For the Bode plot, let's consider the semi-log graph paper as shown in the video and assign the x-axis and y-axis. Our y-axis or the vertical line will be in decibels, and while placing it we have placed that 0 dB, and one above it is a 20 dB. After one below the 0 dB will be minus 20 dB, minus 40 dB and minus 60 dB as shown in the graph. After assigning the vertical axis, let's assign the horizontal axis. For now I have started from 0.1, and then after one decade it's 1, then 10, then 20, then 10, then 100, 1000 and so on. So our x-axis is in omega radian per second and y-axis is in decibels. So our first task is to assign the starting magnitude, which we have find earlier. Of the starting magnitude was 20 decibel, so we have noted the 20 decibel at this place, and 20 decibel. After marking 20 decibel, you need to draw the 0 dB per decade line. So from 0.1 we will have one decade on 1, that's why we have drawn a straight line, but we need to go from 20 decibel to next corner frequency, which is 0.25 radian per second. So we have noted that 0.1, 0.2, 0.25 nearly in the 0.25 place. After that you need to find the minus 20 dB per decade in your graph. We noted that we are having 1 centimeter as minus 20 dB per decade in our graph. So from 0.25, one decade will be 2.5 radian per second. So you need to draw the straight line up to 2.5 and then mark the point. After marking the point, join the both point from 0.25 to 2.5, and while after joining the point, check the table. From the table we can see that our next corner frequency was 2 radian per second from 0.25. So mark the line at 2 radian per second. After marking that, we need to go for the next step. For the next step we are not having any corner frequency, but we need to go minus 40 dB per decade. So from 2 draw the minus 40 dB per decade and join the line, extend it and leave the line. Now after drawing the complete graph, that's how our real Bode magnitude plot is shown, which was initially 0 dB per decade and then minus 20 dB per decade and then minus 40 dB per decade as shown in the graph. Then initial magnitude was minus 20 dB and then next corner frequency was 0.25 radian per second and next was the 2 radian per second. That's how you can draw the magnitude plot of the type 0 system. And next task is to initiate phase plot. For the phase plot, you need to find the resultant angle, and for resultant angle all you need to remember is tan inverse imaginary upon real. And for the given transfer function, our initial factor is constant, which is 10, so there is no imaginary section, that's why it became 0. And for the poles we use negative sign, so minus tan inverse imaginary is 0.5 omega, that's why we place 0.5 omega upon 1 minus tan inverse 4 omega. After placing this, you can substitute the different value of omega based upon your requirement. For now we have placed 0.1, 0.5, 1.2, 1.8, 1.5. Try to assemble them in also a ascending order. Then you can use the calculator as shown in the video. Here we have directly placed the value. It was 0, so we didn't place 0, directly minus 10 inverse 0.5 omega. So for instead of omega we have placed alpha a, then minus 10 inverse 4 omega. Now omega and then bracket close, and you can calculator calc and then substitute the different value as mentioned earlier. Substitute a is equals to 0.1, which gives you minus 24.66 degree. We can directly place it as minus 24 degree. Then similarly again place a at a different value, so calc a is equals to 0.5, and then it gives you minus 77 degrees. In the similar pattern you can substitute all the value of omega and can get the value. After getting all the values from calculator, you can place them in the table. Once the data is acquired, then all you need to do is plot the acquired angles in the graph paper. So for now we have since all the angles are in negative degree, that's why we are consider 0 degree, minus 60 degree, minus 120 degree, minus 180 degree. For the value of omega we get the value as a minus 24 degree. So plot them at the various value of the omega with the free hand and join the each lines in the free hand as shown in the video, and you will get the phase plot. So that's how you can draw the magnitude and phase plot of the type 0 system. If you got any confusion, do mention in the comment section, and like, share, subscribe. Blissy being for more updates. Thank you.